Syracuse Academy of Science and Citizenship. Good morning, third grade citizenship. Welcome to science class with me, Mr. Roney. Today is Tuesday, April 14th. Got a really fun activity planned today, but first I want to congratulate you on some of the designs that you made to muffle the sound from your smartphone speakers that you made. Shout out to Lila for her very creative use of tinfoil. I hope that was a fun activity, and I so much enjoyed the pictures that you sent me of the things that you made. Today we're going to make more stuff, and today's lesson, because of my deep fascination with NASA, is another experiment or project that we're going to borrow from NASA, and it's all about greenhouse gases. Before we get started, let's talk about some vocabulary words that we need to know before starting our activity. First vocabulary word is molecule. Molecules are basically the building blocks of what everything in our world is made out of. So you're made of molecules, I'm made of molecules, there's molecules all around us, but there's actually something even smaller than molecules, and those are called atoms. Atoms are basically the tiniest pieces of matter that we know about on Earth. So atoms are the basic building block of everything around us. Think about Legos, for example. Think about each individual Lego representing a molecule. From those Legos, you can build all sorts of different designs or different kinds of molecules. So atoms make up molecules, which make up everything around us. So when we're thinking about molecules, we have to think about the atoms that they're made out of. Not all atoms are the same. There's a bunch of different kinds of atoms. So when we think about atoms that make up the molecules in the air, there are 4 different kinds of atoms that are very important. The first one is oxygen. You've probably heard of that before. The next one is nitrogen. Then we have carbon, and then we have hydrogen. Oxygen, nitrogen, carbon, and hydrogen. With those 4 kinds of atoms, you can make so many different combinations of molecules. So almost all the molecules in the air have those 4 pieces involved, just in different combinations. Have you ever heard of greenhouse gases before? If you have, great. If you haven't, don't worry about it, because we're going to talk about them. What are greenhouse gases? Greenhouse gases are a specific kind of element in our air and in the atmosphere way up high above Earth. And the point of these greenhouse gases and why they're important is because they act kind of like a blanket for our planet. A planet without an atmosphere and no greenhouse gases, it would get really, really warm when the sun was shining on it, but then at nighttime when the sun went away, it would get really, really cold. What greenhouse gases help to do is they help to trap some of the heat that's brought by the sun and keep it on Earth a little bit longer than it would otherwise be here. So why does NASA care about tracking greenhouse gases? Well, this is a very important part of NASA's job. Because greenhouse gases are so important and they are the blanket for our atmosphere, there's going to be problems if we have too few or too little or too many greenhouse gases in our atmosphere at the same time. So they track over time how much of these greenhouse gases are in our atmosphere. If we had too little of a blanket, what do you think would happen to our Earth? That's exactly right. It would get colder. And if we had too many greenhouse gases, it would be too hot. And that's one of the things now that's leading to a thing called global warming, meaning that the temperature on Earth is slowly getting hotter and hotter over time. And that can cause a lot of problems for plants and animals, and also humans. So NASA really cares about greenhouse gases. Let's learn about what some of these greenhouse gases are. So the best way I like to learn about things is to make models of it. So basically what we're going to do today is make several models of what the molecules of greenhouse gases look like and how they might be different. And what this model is going to be able to show us is how the different greenhouse gases are just different arrangements of those same 4 atom types that we just talked about. Oxygen, carbon, hydrogen, and nitrogen. Just like yesterday, we're going to need to go looking for a few supplies in order to do this. These should be things that you have in your house, and again, if they aren't, you can get kind of creative in terms of how you make your own model. First thing is a blank sheet of white paper, or actually it doesn't even have to be white. Any kind of paper that you can write on is perfect. Then something to write with, markers, crayons, colored pencils, whatever you like. The next thing is probably the hardest thing to find in your house, so you'll have to be a little creative. But what I'm going to use is fruit snacks, all right? The important part about this piece is these are going to actually represent the atoms when we build our molecules. So what you need is hopefully something that comes in different colors. So think about gumdrops, Skittles, M&Ms. Most things like that will work. And even better is if they're soft enough where you can poke a toothpick or something else sharp in order to build these molecules. So I'm using fruit snacks, and I'm going to come up with 4 different colors or 4 different kinds of fruit snacks to represent the 4 different atoms that we're going to use. I couldn't find toothpicks, so I'm going to get real creative and I'm going to use some spaghetti to connect my molecules together. Toothpicks probably work better, but if not, take a few pieces of spaghetti, that should work fine. So lucky for me, my fruit snacks already come in 4 different colors. So I'm going to come up with a system where each color represents a different atom. So I'm going to have pink represent oxygen, purple represent carbon, green represent nitrogen, and yellow represent hydrogen. And then I'm going to make a key so that everyone else who sees my model can tell what each of those colors mean. So your key, when you're done, should look something like this. You have the gummy, or whatever you're using to represent your atoms, next to the name of that element. So again, oxygen, carbon, nitrogen, and hydrogen. And I put the first letter of each atom type next to the name because that's usually how scientists create formulas or shortcuts to represent molecules. So now that we have all of our building blocks in a key, we can start using these blocks to create the molecules that represent our greenhouse gases. So I'm going to put up a graphic that will show you the 5 kinds of greenhouse gases that we are going to make today and that we're going to build. The first one is ozone, then nitrous oxide, then carbon dioxide, water vapor, and methane. So we're going to build all 5 of those molecules. And in this graphic, it shows you how to actually construct it. So in one column, you'll notice that it says formula or shortcut. That's the way that scientists can quickly tell you what a molecule is without writing out the entire name. So each molecule has both a regular name and a shortcut that we use, and we're going to write both of those on our mapping molecules sheet. So let's get started. Actually, why don't you pause the video right here with all of the recipes in front of you and try to build these molecules on your own and label them and put them in the right spots on the map. In a few minutes, you can unpause the video and you can see what mine ended up looking like. A quick note on how to make these. So in the formulas, you'll notice that sometimes there's a little number below the letter in a molecule's name. That little number means how many of those molecules you'll need to build that molecule. Or sorry, how many of those atoms you will need to build that molecule. So for O3, we have to get 3 oxygens and attach them together. So 3 red gummies. Or if you're using a different color, use your own color. When you're all done, your finished product should look something like this. Each structure made with a label either above or below it. I chose to put my labels below. So this is ozone, carbon dioxide, methane, which is falling apart, water vapor, and nitrous oxide. If you notice, I didn't have enough of the fruit snacks for all of the oxygen, so I just drew a little representation in there with a marker. You can do that. Wow, that was really fun and really messy. Quick word of advice, don't use gushers. They spray all over the place, they're hard to connect. Bad idea. Just eat your gushers, use something else. But let's talk about some of the things that we can learn from this diagram or chart that we made. So, a first question that might pop into your head is, if the air and kind of everything around us is made of molecules that look like this, why don't we see them? And the answer to that is a little complicated, but mostly they're just way, way too small for your eyes to pick up on. So you can't see molecules and you can't see their building blocks, which are atoms. The second thing is, what we made is just a model. So if you were able to see them, the molecules wouldn't look exactly like that if you were to get a giant microscope and look at them. But what a model does is basically shows us the main gist of what a molecule structure looks like. And in a molecule structure, there are a couple different parts. There are the atoms that make up the molecule, and then there's the connections, which bond those atoms together and prevent them from falling apart and spraying in all directions. And the structure is what makes molecules much different from one another and what separates greenhouse gases from other kinds of molecules. They basically all work in some form as a blanket for the Earth. So let's review. Greenhouse gases help keep just the right amount of heat from the sun in the Earth's atmosphere so that the Earth doesn't get too cold or too hot. Another thing we learned is that molecules are all around us and they make up basically everything you can think of on Earth. And atoms are the very specific tiny elements that make up those molecules and how they work. Finally, molecules have a couple different parts. They have the atoms that they're made up of, and they have the bonds, which are represented by the spaghetti in our model, that hold them together. So I hope you learned a little bit about molecules today, and your assignment is to make your own version of this chart, and even if you don't have gummies or gumdrops or things that you can stick together, you can still do a model of this drawn by hand. And after that, I want you to try to get the attention of an adult and teach them a little bit about what you learned today. Just give them a 30-second or 1-minute summary of some of the things that you learned. I would love to see a picture, as usual, of what you guys do, so put a comment in Google Classroom or send me a picture in Google Classroom or in private dojo message, and I would love to see what you made. And one last thing, after you teach an adult in your house a little bit about what you learned today and you make your model, it's okay with me if you eat it. That's why it's fun to do science with food. So, bon appetit.